Hello everyone, welcome to FirstNet Lab. In today's section, we want to configure OSPF, the most common interior gateway routing protocol. And we're using the free Cisco Modeling Lab environment. For this section, we're going to connect two routers, get OSPF running on them, advertise our LAN subnet, and test ping across. And most importantly, I'll be showing you the key commands to verify that everything is working perfectly. No theory, just pure practice. Let's get into it. So let's start by logging into CML. And bring up the lab. As you can see, our lab topology has already been set up. We have two routers, router 1 and router 2. They are directly connected to each other on their Ethernet 0/0. Each router also has a LAN network connected to its Ether 0/1 interface. Our goal is simple. First is to configure OSPF on router 1 and router 2 so they become neighbor, advertise the LAN network into OSPF, and verify that each router lands the other's LAN's route. And to make this faster, I have already pre-configured the basic IP addresses on all interfaces. Let's do a quick check and confirm that the layer 3 connectivity is fine before we start OSPF configuration. So I'll bring up the console access to all nodes. On router 1, let's see what we have configured on the interface. So we only have the basic IP address configuration on router 1, the same for router 2. And on switch 1 and switch 2, which is acting as the LAN side, we have IP address configured also. So Ether 0/1 on switch 1, we have the IP address 192.168.1.1 configured, and we also have a static default route. We can see that we should run pipe include those section IP route. So we have a static default route on switch 1 and also on switch 2. We have the same thing. This is for us to be able to verify pings across. So we have the same thing. On switch 2, we have the 2.2 network and we have a static default route on it as well. So that's just what we have configured. So let's go to router 1 and see if we can reach router 2 1 interface by ping 10.10.10.12.2. So this is perfect. We have our pings working across. We only need to configure OSPF now. Configuring OSPF is a two-step process. First, enable OSPF, and second, advertise the LAN network into it. We'll go into the global configuration mode and start the OSPF process using the router OSPF command. And the process ID, which is 1 in this case. The process ID is locally significant. We can use any number within this range. It's only required for in the case where we need to have multiple instances of OSPF running on this same router. It doesn't need to match on the other end of the router. So we'll use router OSPF 1 in this case. Next, we tell OSPF which network to advertise and in what area. We use the network command followed by the network address, the widecast, and the area number. In this case, network 10.10.12.0, that's the one interface of the router 1. Then the widecast is 0.0.3. Then the area number, in this case, is area 0, and that's it. So with these two commands, we have OSPF running on router 1 interface. Next is to get OSPF to run on the LAN interface as well. At the same time, get it advertised into OSPF. So we use the same way. We advertise the WAN interface, which is network, the LAN subnet, which is 192.168.1.0. In this case, this is /24. The wildcard is 0.0.0.255. They will put it in area 0 as well. Note that the wildcard is an inverse of the subnet mask. So we already got everything sorted on router 1. Now let's get router 2 to run OSPF as well. We'll go to the global config mode and start the OSPF process. Router OSPF 1. Then we advertise the link between the two routers, which is network 10.10.12.0. The wildcard is 0.0.0.3 in area 0. We should have OSPF adjacency form, right? We can see that we have a neighbor already from loading has gone into full state. And the next thing is for us to advertise the LAN subnet of router 2 with network 10.10.12. Sorry, that's 192.168.2.0. Wildcard is /24 0.0.0.255 in area 0 as well. Now we're done with configuring OSPF on router 2 as well. Now let's verify. The first command is show IP OSPF neighbor. And we can see we have a neighbor with the neighbor ID of this. We did not assign a router ID, so the OSPF picked the IOS IP address on its interface, on this router interface, as a router ID. It's a good practice to assign a router ID, but for this sake, we'll just let it go by. So we can see the state is full, which is the expected state, and we can see we have the address is 10.10.12.1, which is the router 1 interface, and it's forming this neighborship on this interface Ethernet 0/0. Now let's also verify if OSPF has actually added the LAN subnet into the routing table. So IP route OSPF. Fine, we can see that we have the O indicating OSPF route length, which is the router 1 subnet. It's learning it via OSPF, and it's coming from the router 1 interface. This has been learned in 5 minutes now. The Ethernet interface from Ethernet 0/0. And if we do the classic show IP route command, we can see as well that that's the only route we learned via OSPF. Every other route is locally connected. That's it there. So this shows that OSPF is running and we are learning the right route. We can also do the same verification on router 1. We are saying show IP OSPF neighbor. We can see this as well, our neighbor ID, which is router 2, the IS IP address on router 2. We can see the address 10.10.12.2 of the router 2 1 interface, and the neighborship is coming up on Ether 0/0. And then show IP route OSPF. We see that the same thing again. We have learned a route via OSPF, and that is the 192.168.2.0/24 network, and that is coming, that is router 2 LAN interface. And the classic route show IP route command, we see that that's the old route length via OSPF. Another nice command to verify OSPF is to say show IP OSPF interface brief. Yeah, this command gives us a nice summary of which interfaces on the router that are running OSPF. As you can see, we have OSPF running on these two interfaces on this router, and then if you looked at it, we are running OSPF on Ether 0/1. It is really inefficient and unnecessary to have OSPF running on this interface because we do not have any OSPF router on the other end here. So it will make sense to turn off OSPF and stop OSPF packet being LO packet being sent out of that interface, and we can do that by going into the global config mode again under the OSPF router OSPF 1 and say passive interface Ether 0/1, and we'll do the same thing on router 2 config T router OSPF 1, passive interface ETA 0/1. Now we've stopped OSPF packets, LO packet being sent out of that interface. And then we can also still verify show IP route. We're still getting our LAN interface advertised to us, coming to us via OSPF. So OSPF is still running on that interface. Like the LAN subnet is still advertised, but OSPF LO packet are not being sent out of that interface. We can go to our switch now to verify if we can ping across. From switch 1, we have show IP interface brief. We can ping the other end, which is 192.168.2.2, and that's fine. We can do a trace route 192.168.2.2 to see issue 8 gateway, which is 1.254. Yes, and the next should be the router 2.1 interface, that's 12.2. Yes, and then the next should be the device, the IP address itself we are pinging. So that's fine. We can also verify from switch 2 as well, the same thing, ping 192.168.1.1, which is route switch 1. So this confirms that we are able to reach end-to-end successfully. And there you have it. We have successfully configured OSPF, advertised our LAN subnet, and verified using end-to-end pings from our end devices. If this video helped you, smash the like button and consider subscribing for more practical lab like this. Thank you for watching, and I'll see you in the next one.